So this is the first video of our malware development theory series. So in this video we are going to learn what a reverse shell is and what a bind shell is. What is the difference, and we will see it practically in this terminal which I have opened in my Linux machine. So just let me zoom it a little bit. Okay, I think it's clean enough. So this is my home folder or home directory, as we say in Linux. Let me go to a temporary folder. So for example, the dev shm is one of my favorite temporary folders. So the difference between a normal folder and a temporary folder is that temporary folders generally refresh each other. So the files in a temporary folders within a certain period of time gets deleted by the system itself. Okay, so don't save your important files in this folder, so that is a caution. So okay, here there is a file same.havesame. Just ignore this file. So it is, I don't know what, but it is some kind of system file. Just ignore this, and let's head into our topic. So let's just explain it in layman's language. A reverse shell is a shell where the attacker, in our case we are the attacker, so we are awaiting, we are listening for connections. So when connections from another computer, which is particularly our target computer, so that is the victim, so when he connects to us, we receive his connection and he connects to us with the access of his own terminal, with the access of his own shell. So that is how a reverse listener or reverse shell works. So let me just show you. So I have this Windows machine. So let's just put the password and log in. It's taking time, my system is lagging, sorry for that. Yeah, the CPU usage is 80, about 90% sometimes. So let's just wait for that. Till then, let me just show you what a fantastic program is netcat. So I will open a terminal side by side. So okay, let me just show you how networking works, the wonders of networking. So there is a program called netcat, that is you can also write netcat, but in short form nc is written. So in netcat we have the client server model. In every bit of networking we have the client server model. So there is a server which is listening for the connections, there is a client which connects to the server. So if you want to listen for connections using netcat, that is a basic TCP listening, so you have to mention this switch -nvlp, and what it just means is that we have to listen, the netcat just listens. So and then we have to write a port number, and if you know, in networking the range of port is from 0 to 65535, and any network device which is capable of doing networking, any computer, any mobile or anything will have this amount, total 65536 ports, 65536 ports, which if I show you 2 to the power 16, total there is 2 to the power 16 ports in any computer, in any operating system to be specific. So we have to mention any kind of port number. So So nc-nvlp 443. Let's just listen on this port, and now this is a server. This is a TCP server. This is listening for connections. So now we have to connect to that server. So for that we can also use a netcat, and so we have to mention an IP address of our machine and the port number. So if you know basic networking, you know about loopback address. So a loopback address is 127.0.0.1. So this, when you dial this address, it is just referring to your own device only. So in any device, if you write this address, it is only going to refer back to your own device. That is why it is called loop back to your own device. And then there is the port number. So we are connecting to this host and to this port number. This is our primary host, and now this is the port on which our server is listening. So, and there is what a connection received, which it says. And now let's say I write hello from the server side, and then we receive hello on the client side. Let's say, hi, I am the client. So we receive that in the server side. So that is how it is client server model basically works. So now when you understand that, let's set our listener again, and now we are going to listen for shell connections. So this listener is perfect. There is nothing to do with this listener, but there is something we have to do with client. So normally netcat connects in the message mode. So when we connect to the server, we can pass messages from both the server and the client side. That is how basic networking works. But now we want this shell access, so we write this very command, and we provide a switch, that is -e. -e is another option. So we provide this option with a value. That's what shell do we want to have. So we want to have /bin bash, and if you are familiar with Linux, you know what this is. So this is very basic, I think. So now if I write any shell commands, for example, who am I? So we do not receive who am I on this side, but we receive root on this side. So we have a reverse connection. Now if I have to show a bind shell connection, so let's netcat nvlp, that's listening 443, and now we are executing the bin bash on the server side. Now when we connect to 127.0.0.1 and 443, and now we don't connect with this -e bin bash because this here is bind shell. So in bind shell, the server listens for connections, and when a client successfully connects to the server provides the client with the access to the server's shell, not the client's shell. So this program, the bind shell, is usually run on the victim computer. So when the attacker connects to the victim computer, the attacker gets the victim's shell or the terminal access. So if I route now ls on this client side, we have this is the thing that is under dev shm. So let's write who am I. So root. So can we get /etc a file named password? There is a file, so we can get it, we can read it, and clear also works perfectly. And again, who am I? So we are root, and this is how a bind shell works. That is the difference. And now I will also show you this in action to this Windows machine. So that was a demo, and now this is like of a more of a practical. So let's get into the desktop folder, and do I have a temporary directory up? I think I have, that is the opt, and just zoom it a bit, so that's, I think, fine. Now let's just don't ignore this directory. There are projects, just ignore this directory. And now we are going to access. Let's first demonstrate a normal reverse shell, which is mostly used. So I will discuss why we use reverse shell mostly, and why the bind shell is used very less. I will explain that in a moment, but let me just show how the reverse shell works in case of a Windows computer. So in this computer I have, I think, netcat installed. Yes, I have. So netcat dash help dash h. So we have netcat installed, but normally there is no netcat installed in Windows computers. So we are going to use metasploit framework, but for that we have to disable the defender, because the defender can detect the metasploit framework malwares very easily. So we cannot just let the defender run. So turn off real-time protection. Yes. Okay, let's just cross it. Now first of all we have to generate a reverse shell malware, and in technical terms it is not called a malware, it is called like of a payload. So let's an exe payload. So for that, in metasploit framework, and note I am using the term metasploit framework because it is a framework, it has a lot of tools. One of the tools which we use is called MSF Venom or Venom. So MSF Venom is a tool which creates payloads, and it is previously it was known as metasploit payload, MSF payload, because it generates payload. So now dash p is an option from MSF Venom which says what payload we want to use, and we don't want Linux, we want Windows, and we can mention the architecture of our payload, that is x64, though it is not essential in case of Windows because it just assumes the architecture and we are good to go for that. But now just for fun, let's just write x64, that is 64-bit operating system. We have the Windows, that is this target machine, and then we have shell underscore reverse underscore TCP. So first of all let me explain. The shell part means we want a CMD shell, that means a shell access of the CMD, which is this CMD. Okay, so this is the CMD, this is the CMD. Okay, so we want the access of this CMD. Now this underscore denotes this is a staged or unstaged payload. So I have discussed the idea of staged or unstaged payload in my previous video. You can watch that, but I will explain it in another video also, but not today. And then there's reverse TCP, reverse in the sense reverse shell, and TCP, of course, this means the protocol that is used, networking protocol, that is TCP. So and we have to pass on the parameter lhost. Lhost means the local host. What is local host? Local host means the IP address of the attacker to which the victim should connect. So in our case, the local host address we will use is 192.168.51.75 because we are not using the 127.0.0.1 because this computer is connected on another network. So if I, let's say, list the network address, so for that the command is ipconfig, by the way, and we have 192.168.51.88, and these are the network bits. So it says this device is a part of the 192.168.51 network, and then the host bit is 88. So, and in our case, let me just show you another terminal. ifconfig WLAN 0. So let's just so we have the IP address 192.168.51. We are the part of the same network with the host bit 75. So that is why we are using this address. So this is how we are ensuring that this Windows client can connect back to this Linux one. So that is why. And then L port, that is a local port of a server. So on what port the server is listening? In our case, the server is listening on 443. Okay, I think I am making sense. And we also just mention exit func, though it is not necessary. Exit func equals thread. It just means that the process, let's say the payload executes in a new thread. That means it runs in a background. When you execute the file, when you just run the program, it runs in the background and the program exits. Okay, the program does not stays there and waits till the connection is ended. So okay, so the program runs in the background. That is why exit func equal to thread is used. Now the -f means the format on which we want the payload to be, and in Windows we execute -exe files. There is some files which are named .exe. So exe files get executed in Windows. That is why we want the exe format, the payload in exe format, and that there is an -output, that means in which file do we want the payload to be. And in our case, we want the file name to be payload.exe because it's an exe file. Let's just run that command and wait till it's done, and then we have to just transfer the file to this machine. So it is saved as payload.exe, and I think I have the payload.exe here, so that's good. And now to transfer the file to this machine here, I have the basic idea, that is we run a python 3-m http.server. We run an http server which serves the files. Okay, so let me just show you how it works. Let's go to our current IP address 127.0.0.1 on port 80, not 8000, on port 80, and we have the payload.exe. If I click on this, it is going to download that. I am not downloading it, but it is going to download that. So now, and you see we have this IP address, this logs here. Okay, so now for downloading the files, we have the setutil command in Windows. We pass the parameter URL /, that is the basic parameter, -split -f, and we just mention the IP address 192.168.51.75, and port 80 is the normal port for HTTP, so it's going to assume port 80, so we don't have to mention that. And we can just write payload.exe. We want that file to be saved in, and what setutil is going to do is that it is going to download the file. So if I just list the files here, so we have the payload.exe, and if I execute the payload.exe, I suppose we are going to get the shell here. So just execute it, and see the payload.exe exited, and we got the terminal because it executed the payload in background, in another subthread. So that is why it exited, and we also have the shell access here. So dir works. CLS won't work, but c dot dot who am I, who am I works. So okay, this is how a reverse shell works. Okay, I think I am making sense. And for bind shell, we just have to bind shell bind TCP, and is there help? How to get help? How to get help? Yes, there is a list options. List options. So we'll have options for shell bind TCP. So it's gonna take some time. Yes, and there is the exit from process. L port we are going to set, and there is R host. So in this case, L port means the local port on which the server, in case our victim is going to listen, and let's just we will set that. And R host means the IP address of the victim, not the attacker, the victim. So MSF Venom, our host will be the 192.168.51.88. that means the IP address of this server. That will be the our host, and the L port will be let's say 4444, though it assumes 4444, but let's just make sure L4 4444. And of course exit func, we like it to be thread, or let's just not mention that for now and leave the exit func to be processed. So it will not execute in background, it just runs. And the format is of course exe, and the output is always payload.exe, and I am going to override that file, so now payload.exe will contain shell bind TCP, bind reverse shell, not the reverse shell, bind shell it will contain. And in here we just remove payload.txt, that is we delete the file, and if I show you, it is deleted, you can see. Now Python 3 server is running, and let's just download that again. So if I show you, I have payload.exe here, it is running I think, and if I connect to the port 192.168.51.88 on port 4444 should, and yes, we got this shell. Who am I? We have development net. Control C. Can we connect again? And no, the connection is refused because the program has exited successfully. That is how the bind shell works. So payload.exe. Okay, so I think I have demonstrated how bind shell and reverse shell works. Let's just cross this and we are done. So this is it for the video, and now please of course like, comment, share and subscribe to the channel, and also don't forget about the bell icon to receive more videos like this in the future. And till then, take care and bye bye.